Hello, everyone. I hope you're having a great day. We're going to talk about solving applications with rational equations. So I'm kind of making that face because they're word questions and rational equations. So, all right, lots of reading in this section, lots of reading, a couple times. All right, read, and then read again. Draw pictures if you can. Define your unknown. Check your units, make sure your units are in the right places. When you have something in the numerator, something in the denominator, make sure it stays in the numerator and stays in the denominator. And then once you solve, kind of think about it. Does your answer make sense? Okay, so I know that's kind of hard to say, but sometimes you just kind of have to look at it and say, is this something that makes sense? All right, let's look at this first example. A 4-foot boy casts a 6-foot shadow. How tall is the flag which casts a 12-foot shadow? Okay, so in this case, I am going to draw a picture because I can. Here's my boy. Here's his shadow. So he is 4 feet. And the shadow is 6 feet. And then it says, how tall is a flagpole or a flag which casts a 12-foot shadow? So flag, I'm going to write here. So that's going to be my F. I'm going to go ahead and so I'm using F, and I'm defining F as the flag, but it's more specifically F is equal to the height of the flag. And here's my 12-foot shadow. So now, height, and then is going to go over shadow. So my first fraction is 4 divided by 6. Could you reduce that? You actually could. I'm not going to worry about it though right now. Equals F divided by 12. So do you see how my heights are both in the numerator and my shadows are both in the denominator? Now I have a proportion. How do I solve a proportion? Cross multiply. Absolutely. 6F is equal to 4 times 12. So 4 times 12 is 48. Divide both sides by 6. F is then equal to 8. So that means the flag is 8 feet tall. There's my answer. All right, let's look at the next question. Kevin wants to keep his heart rate at 160 beats per minute while training. During his workout, he counts 27 beats in 10 seconds. How many beats per minute is this? Okay, so let's look. We have beats in seconds. So I'm going to go ahead and say beats over seconds. Oh, my eraser is pretty big right now. Beats over seconds. Now, I'm going to write what they give me. They give me 27 beats over 10 seconds. How many beats per minute is this? Equals. Okay, so in my denominator, I'm looking for my beats. So I know I'm looking for B. So I'm going to go ahead and label that as beats. And now I want beats. B is equal to beats per minute. But I have it over seconds. So right now, I have to then change my minutes to seconds, which means it's 60 seconds in 1 minute. All right, now I need to solve. So once again, I have a proportion. I can cross multiply. So I get 10b equals, so then I have 27 times 60. So 27 times 60. Can see my answer very well. So I get 1,620. There we go. 1,620. Divide both sides by 10. So I have beats is 162. So in this, for what he was measuring, he has 162 beats per minute. It says, has Kevin met his target rate? Well, here, his heart rate at 160 minutes or 160 beats per minute. So has he met that? Yes. All right, let's look at the next example. The pediatricians prescribe 5 milliliters of acetaminophen for every 25 pounds of a child's weight. How many milliliters of acetaminophen will the doctor prescribe for Jocelyn, who weighs 45 pounds? All right, so I'm going to go ahead and start here with milliliters over pounds. So 5 milliliters for every 25 pounds is equal to how many milliliters? So milliliters is going to be prescribed for Jocelyn, who weighs 45 pounds. So M is equal to milliliters of acetaminophen for Jocelyn. Once you're using a variable and I ask you to define the variable, just make sure you tell me what that variable represents. That's what defining a variable means. So now I need to solve. So I have 25 times M, and then I have 45 times 5. So I have 225, then 225 divided by 25, and I get 9. So Jocelyn would be prescribed 9 milliliters of acetaminophen. Next question. Phil wants to fertilize his lawn. Each bag of fertilizer covers 4,000 square feet of lawn. Phil's lawn is approximately 13,500 square feet. How many bags of fertilizer will he have to buy? All right, so each bag, so bag of fertilizer, and then square feet of lawn. So now we know that one bag covers 4,000. Well, we're looking for how many bags. I'm just going to go ahead and say X over 13,500. All right, so my X is the number of bags of fertilizer. Now I have a proportion. How do I solve a proportion? Cross multiply. 4,000 X is equal to 13,500. So now I'm going to take my 13,500, divide it by 4,000. All right, so I get that X is equal to 3.375. So how many bags is he going to have to buy? 4 bags of fertilizer. So this has nothing to do with like rounding this particular number. As soon as if it's more than 3 bags, it doesn't even matter if it's, 2 cupfuls over 3 bags. Well, how many bags do you have to buy? You're going to have to buy that 4th bag. So there's no, I didn't round, because if you're looking at rounding 3.3 to the nearest bag, it would be 3 bags. But you can't round down when you're using something like that. So it's got to be 4 bags. All right, variation. When 2 quantities are related by a proportion, we say they are proportional to each other. Another way to express this relationship is to talk about the variation of 2 quantities. All right, so you're going to make sure that you're going back and using these examples that are written right here for you. K is your constant in your variations. So when you see Y varies directly with X, you would then write Y equals K times X. If Y varies inversely with X, then you write whatever is here, which in this case is Y, equals, and then you say K divided by, and then whatever's written here, which in this case is X. And then you have Y varies jointly, which means it's all multiplication. All right, so let's look at these examples. If A says W varies directly as B, and W equals 12 when B equals 8. So what are you doing here? You're actually finding what K is equal to. But we're just going to go ahead and write, it just says write the variation equation. So I'm going to start off with what it says. It says W varies directly. So W equals then K times, and then B. So B. I'm getting that right from here. You're writing exactly what this says. This time, what am I using? I'm using W and then B. So that's all I did right there. So then writing the other part of the equation, I would write 12. 12 is equal to K times 8. So I'm not going to solve here. I'm just rewriting it. Later on, we're going to solve them. Let's look at B. As I was getting ready to do this B example, I realized there was something written incorrectly. So I went ahead and crossed out that M, and then it should be W. All right, so now I'm going to go back up here and look. This says Y varies inversely with X. So now this one says W varies inversely as Y. So in this equation that I have here, I'm replacing the Y with W and the X with Y. So I would be, when I'm given something that looks like this, I would write W equals K divided by Y. And then then it says W equals 11 when Y equals 4. So 11 equals K divided by 4. All right, let's look at the next example here. My next example says, write the variation equation. Y varies jointly as X and W. So here I have my jointly. Jointly just means that what are they all doing? They're multiplying by K. So Y equals K times X times W. Then I have 25 equals K times 10 times 6. So 25 equals 60K. And then you would solve for K. All right, so now let's look at some of the examples that you'll see on your homework. If Y varies directly as X, so Y varies directly, I see that I have the word directly, so I'm going to come up here and I see that directly is that multiplication. So I'm going to go ahead and write here then, Y equals K times X. So then I have Y is 14 equals K times 3. So K then equals 14 thirds. Find the equation that relates to X and Y. So Y equals 14 thirds X. So it's 14 thirds X. So all I'm doing is just finding K and then plugging it into the equation. Next example. If P varies directly as Q, so P varies directly again, so K times Q. And then P equals 9.6 when Q equals 3, find the equation. So P is 9.6 equals K times 3. Divide both sides by 3. So I have K is equal to 3.2. So therefore P is equal to 3.2 Q. Looking at the next example. Y varies inversely with X. So this is exactly what this says. Y varies inversely as X, so I'm going to use my division. So Y equals K divided by X. So then I have 5 is equal to K divided by 4. I get K equals 20. Then I'm going to write Y equals 20 divided by X. All I'm doing is finding K and turning around and replacing my K in my equation. If V varies inversely with W, so inversely means I'm going to divide. So V equals K divided by W. V equals 6. K divided by 12. K then equals, multiplying those together, I get 72. So therefore, V is equal to 72 divided by W. So number 317 from the book. The price P that Eric pays for gas varies directly with the number of gallons he buys. It costs him $50 to buy 20 gallons of gas. Write the equation as it relates to P and G. So the price is my P, right? And it varies directly. So P equals K times G. It cost him $50 to buy K times 20. Divide both sides by 20. So I get K is equal to And I would go ahead and divide this and write it, I'm not going to leave it as a fraction here because it's going to be a fraction that ends anyway. Right? So I get 2.5. So 2.5. So then P equals 2.5 times G. So 2.5, $2.50 per gallon. How much would 33 gallons cost Eric? So now I'm using what I found here. So my price that I would pay is going to be 2.5 times 33. So 2.5 times 33. And I get my price I would pay would be $82.50. The time required to empty a tank varies inversely as the rate of pumping. All right, so I'm going to go ahead and I'm going to label some variables first. So time required to empty varies inversely as the rate of pumping. So time and then P, or you can do R, whichever one. So if it varies inversely, T is equal to K divided by P. T is the time required to empty and P is the rate of pumping. So know where those are. It took Ada 5 hours to pump her flooded basement using a pump that was rated at 200 gallons per minute. That was the rate. So now in that second equation, they're giving me values to find my K. So 5 hours, that's her time, K divided by the rate of the pumping, which was 200 gallons per minute. Cross multiply, so I get 1,000 equals K. So now my time is equal to 1,000 divided by P. So how long would it take Ada to pump her basement if she used a pump rated at 400 gallons per minute? So now I'm using what I found. So now time is going to be 1,000 divided by 400. So 1,000 divided by 400, and I get 2.5. Now, one of the things that you do is you go back and say, is that something that makes sense? Well, yeah, the first rate was 200 gallons per minute and it took her 5 hours. If she gets something that is 2 times as fast, now it's rated 400 gallons per minute, it's going to take half the time. So, just kind of go back and say, does that answer make sense? I hope that helps. You have a great day.